going to identify the cations and anions, means a positive ion and the negative ion present in our given salt. Okay, so I have been provided a salt which is blue crystalline salt here. Okay, so I have to detect the cation present in this salt. For this, for the detection of cations, we always use alkalis. Okay, we could use strong alkali as well as we could use weak alkali. So I am going to use both the alkalis for the detection of cation in this salt, and by the use of alkali, the metal ion get precipitated out in the form of their insoluble hydroxides. Okay, so let us first take the small amount of salt in our test tube, and then we have to prepare the solution of it. Okay, because the ions present in the salt are held together by the strong electrostatic force of attraction. So I have to add this small amount of water in it. I have added the water. Now I have to make the solution of this. So I am going to make the solution of the salt so that it becomes slightly solid. Due to the high dielectric constant of water, the salt will get dissolved in this. Okay, so I am having the solution of my salt. Now I am going to add my strong alkali NaOH in it. Okay, so upon the addition of NaOH, let us observe that what happens. Now if I added the NaOH in small amount, I could observe that a pale blue precipitate has been formed here. Okay, a pale blue precipitate has been formed here. Okay, if I keep the solution for some time, then this precipitate will settle down. Okay, so the pale blue precipitate formed here, it is floating in the solution. Okay, now if you add NaOH in excess, then observe what happens. Now I added NaOH in excess, so no change in the pale blue precipitate will be observed here. The pale blue precipitate remains insoluble. Okay, the particles of the precipitate are in floating motion, are present in the floating motion in my solution, isn't it? Okay, so now let us observe the change in my given salt solution by the addition of weak alkali. Now the formation of this pale blue precipitate confirms that the cation present in my given salt is copper ion. Okay, so when you take the small amount of salt in your test tube and you add the NaOH to it, and you get a pale blue precipitate like I have got in this solution, the formation of pale blue precipitate which remains insoluble in excess of NaOH proves the presence of copper ions in this given salt. Okay, now let us use another alkaline solution for the detection of the cation in the same salt. We are going to do another experiment for the detection of basic radical or the cation present in our given salt. For this, now I am going to use the weak alkali NH4OH. For this, again I am going to take the small amount of salt in my test tube, and now we have to prepare the aqueous solution of the salt. For this, we have to add water in it, isn't it? Now I am going to dissolve my salt in water. Okay. Now my salt has been slightly dissolved in water now. So let's we add the weak alkali ammonium hydroxide in this solution. This is ammonium hydroxide. Okay, so first we have to add this small amount of ammonium hydroxide in the given salt solution. So now I am adding it dropwise. By the addition of this weak alkali dropwise, you could easily observe that you get a pale blue precipitate here, isn't it? So if the small amount of ammonium hydroxide is added to this solution, to the solution of the given salt, the pale blue precipitate is formed here. It is easily visible here, isn't it? Now what happens if you add NH4OH in excess? If you add ammonium hydroxide in excess to it, let's observe that what happens. Here, look at the salt solution now. It gets converted to deep blue, isn't it? You will get a deep blue or inky blue solution here upon the addition of excess of ammonium hydroxide to this. Okay, so the formation of pale blue precipitate upon the addition of small amount of NH4OH solution to this salt, and upon the addition of excess the formation of deep blue or inky blue complex proves that the given salt contains Cu2 positive or copper positive ions. Okay, so the basic radical or the cation present in my given salt is copper ion. Okay. Yes class, now we are going to detect the acidic radical or the anion present in our given salt. For this, now I am going to take the small amount of salt with the help of this spatula into my test tube. Now I have taken the small amount of salt in my test tube here. Now I am going to add the dilute acid to it. Okay, as we know that the acids show their acidic property in dilute state, so I'm going to add the small amount of this dilute hydrochloric acid to it. Okay, let's see what happens. So here you could see that brisk effervescence of carbon dioxide observed here. Now I'm going to pass the gas evolving through my test tube into lime water. This is the lime water solution. Okay, now I'm going to pass this gas into the lime water. Let's observe what happens here. As you could see that the lime water is getting milky, isn't it? When I have taken the lime water, initially it was transparent. Now slowly my lime water in another test tube is getting milky. It is getting translucent, isn't it? So since the lime water get milky, it proves that the gas evolving with brisk effervescence from the first test tube was carbon dioxide. Okay. Now let us do one more test to confirm that the gas evolving from the given salt is carbon dioxide. Okay, so let us take the small amount of salt in our test tube. I have added this given salt in my test tube. Okay, now let us do this. Repeat the same experiment. We are going to add dilute hydrochloric acid again into the salt. Okay, so let us observe what happens. Again, here a gas evolved with brisk effervescence again, isn't it? So now let us confirm that the gas evolving is carbon dioxide or sulfur dioxide, because both the gases turns lime water milky and both the gas evolved with brisk effervescence. Now let us observe that whether the color of KMnO4 changes or not. So we can see that there is no change in the color of KMnO4 solution here, isn't it? Potassium permanganate, the color of purple color of the potassium permanganate is not changed here. This proves that the gas evolving from the first test tube is carbon dioxide, isn't it? Because carbon dioxide have no effect on the potassium permanganate or potassium dichromate solution, while the sulfur dioxide, it changes the potassium permanganate solution from pink to colorless and potassium dichromate from orange to green. So here I have taken the potassium permanganate solution and the gas evolving from a first test tube have no effect on this. It means the gas evolving from the first test tube is carbon dioxide. It means that upon the addition of the gas, since upon the addition of HCl the gas evolved have no effect on the KMnO4 solution, it means that the gas is carbon dioxide and the radical which was present in my given salt was carbonate ion, isn't it? So the acidic radical present in my given salt was carbonate ion. Okay, that's all for today's video. Thank you so much, class.